So, welcome to the ZK Hack. This is the event that we have been planning for the last few months. I'm very, very excited that you're all here. The event is put on by the Zero Knowledge Validator and the ZK podcast, both kind of entities that I work with or for or host. And this is a chance for actually both entities to come together and build something focused on the ZK community. So quickly, what is the ZK Hack? It's a 7-week event series and puzzle competition, as mentioned, brought to you by the Validator and the podcast. And I want to give you a quick sense of what it's like. So we're going to have workshops and puzzles. The workshops aim to introduce you to new ZK tools like ArcWorks, Circom 2.0, Cairo, Aleo, Aztec Connect, Snarkyjs. And we're going to be doing puzzles at the same time, which are basically broken advanced cryptography protocols that you need to find the bug in and exploit. There's there's prizes, there's a leaderboard. It's very exciting. Here's a little sense for how the flow is going to go. We have 7 of these workshops. So each one is 1 week apart. It'll always happen on Tuesdays around like now-ish. And yeah, each one is a 2-hour session focused on some of these tools that you could use to build ZK stuff. At the same time, and I know this looks a little complicated, but at the end of every session, we announce a puzzle. There's then 1 week to basically work on that puzzle. And in the subsequent week, at the beginning, we announce the winners. So yeah, a little bit about ZK Hack. Why do this? Well, with ZK Hack, you can learn about applied zero-knowledge cryptography. We're hoping that through this, we can onboard more people into the ZK space and form more connections, collaborations, and we really hope that there could also be new ideas that come out of this entire process. Now, we originally wanted to do this as like a hackathon, but the truth is the tools aren't quite ready yet. So instead, we've decided to do the ZK Hack. The place where we're going to be hanging out and talking a lot is on Discord. If you're not already there, please do join. Let's add the link to that if you guys can find it. And also follow us on Twitter. I wanted to share a little bit about the team that is doing the ZK Hack. It's myself, Kobe, Susanna, and Tanya. And we've been working, for I guess like a couple weeks on this. The idea for the puzzles definitely came from Kobe. He had this idea like, if we can't do a hackathon, maybe we could do broken puzzles. All right. But at the same time, we couldn't have done it without these partners that we brought on, Anoma and Aleo. So both of these teams actually use dev time and talent to build the puzzles that you're going to be hacking on. So there's 6 of them. Anoma did 3, Aleo did 3. And I want to say a big thank you to these partners. We also have our gold sponsors, Aztec, IDEN3, Starkware, and Mina. So basically these 6, the gold sponsors and the partners, those are the folks who are going to be doing workshops over the next 6 weeks. And I'm actually going to be bringing them all on stage very shortly to get to know them. I also want to say a big thank you to the silver sponsors, Figment, Kedit, Horizon, Osmosis, Geometry, Celo, and Polychain. Some of these teams have also sponsored prizes, so you'll hear more about that as we announce the puzzles. And there are also the bronze sponsors, Lambda, Aleph Zero, Penumbra, Manta, Panther, and Status, as well as our media partners, ZK Proof and Zero Knowledge Soul. So what can you do at the ZK Hack? You can visit a workshop, which you're doing now, hack a puzzle, win a prize, and hopefully meet your future collaborators in the ZK space. This is basically the schedule for the following weeks. This is actually all available on the zkhack.dev site. This week, we're doing an introduction to ZK Snarks and ZK DSLs, actually. Next session is with IDEN3, looking at Circom, Starkware, Anoma, Aztec, Aleo, and Mina. This is basically the flow you can expect. As each one of these folks are presenting, we're going to be sharing an individual hop-in link for their event. So and if any of these are sessions that you want to visit, be sure to sign up then. But don't worry, we're going to show those as everyone is speaking. And for today, this is the intro to the ZK Hack. After this, we're doing workshop host presentations. So this is the sponsoring teams. Then we're going to be hearing from Alessandro Chiesa on how to make snarks, snarks from hash functions with Nick Spooner, snarks from polynomial commitments with Pratyush Mishra, and then an intro to ZK DSLs with Alex Ozdemir. And I think in the Discord, somebody did share a previous talk from Alex at another ZK Sessions event. This will be, I think, an updated form of that. So I'm very excited to see what he has to say. And at the end of this, we're going to be doing the Puzzle 1 kickoff with Kobe. And Kobe will tell you more about the puzzles that he and the teams designed. Cool. So yeah, as mentioned, it's going to be at the end of the session that we share more about it. We're using ArcWorks for these puzzles, and we do have some documentation available on the site. Watch out for announcement about the puzzles here and on Discord. And I quickly mentioned prizes. I just want to kind of tell you a little bit about them. Every week, there's going to only be the top 3 who submit in time, the fastest with the best. Those are the ones that are going to be awarded. But I very much recommend that you consider submitting a puzzle solution, because at the very end of all 7 weeks, we have a lot of really interesting gifts and prizes that will go to leaderboard participants or folks that end up on the leaderboard. Cool. So that basically is the intro to ZK Hack. I am so excited to have you all here. I think actually our first speaker might be ready to come up. Let's just check it out. Hey.
Hello, Anna. How are you doing?
How's it going?
Very good.
I just realized I forgot to mention something to anyone listening who might know me from the podcast. Normally my voice sounds a lot better than this, but like last week we had this ZK Hack kickoff party in Lisbon and I still haven't recovered. So anyway, Jordi, welcome to the stage. Now we're going to hear from Jordi Baylina all about Circom 2.0 and the workshop that he has planned. Take it away.
Yes, well, next week and next Tuesday, we are going to do the first workshop on the Circom 2.0. As you know, most of you, Circom has been fully rewritten in Rust, has been at work for the last year and a half. So right now we have let's say a professional compiler, a compiler that can be audited quite well. We have been used all the experience of the Circom 1 for testing and so on, and we have this thing. It's still new because we just launched it last week, but it's we make a lot of tests and it's quite compatible in what I would say very much production ready. We're finishing some documentation and still, well, it's a work in progress that will never finish. But for the workshop, mainly what we are going to do is we're going to talk. We'll divide. Let me see if I'm just can move the slide, just one single slide. But the idea is, we'll divide more or less in 3 sections. In one, we will do a little bit more theory about creating circuits and so on. It will be a complementary of the talk the talks that we will have today. This we will try to keep it short because today all the theoretical part should be understood from the today talks, and then we will go hands-on, where we will do a real Circom. We will do a kind of a voting system. Actually, it's checking a consensus and just a real circuit. We'll go from the beginning to the end, creating the circuit, creating the test for that circuit, verifying that circuit in the smart contract. So we will do the full hands-on from the beginning to the end. That's from the workshop. And then at the end, we also will talk about the Circom 2.0, the difference between 0.5 and the Circom, so the lost Circom and the new Circom. And we will also talk about all the constraint optimization, which I think is good. But it's interesting to see how we are doing, how we test that, and how we improve. So we'll talk about this. It's just introduction, hands-on on Circom 2.0. Be ready to be prepared to learn the Circom 2.0 and create your first circuits on there. And then just for the people that are already running Circom and so on, they can see how to port to the new Circom 2.0, what are the main differences and so on. And this is that. So I hope you all the developers that are interested in that. I think it's going to be fun, and yeah, very excited for all the hack.
Very cool. Thanks, Jordi. I'm going to invite Tom up to the stage next. And I think your slides are also ready. Hi, Tom. So this is Tom from Starkware, who's going to be sharing a bit about the Starkware session.
Yeah, so hi. Thank you for having me here. I mean, unlike Jordi, I'm an unknown. So my name is Tom. I've been working at Starkware for the past 3 years. And I had the pleasure of like 3 years ago hearing about zero knowledge proofs from Eli Ben Sasson. And I mean, I've decided to join Starkware from the realization that I see no future for blockchains in which zero knowledge proofs are not part both of the scaling solutions and the privacy solutions. So for me, I'm very excited to be here today with all the other projects that are trying to make this a reality. And this brings me to what we're building at Starkware, which is Starknet. So Starknet is a decentralized permissionless ZK rollup, which operates as an L2 network over Ethereum. And basically it features an Ethereum-like state in the sense that you can write general computation smart contracts that are composable with each other. You can deploy them on Starknet and operate the same way you do with Ethereum. Starknet Alpha is live since last June. And we're constantly updating it, and we're aiming to release the alpha version on mainnet in a month from now. And actually the technology that Starknet is built upon, both the ZK rollup and the Cairo, is already on mainnet since June last year, and processing like $1 billion of trading volume each day. And this brings me to the workshop, which will be on Tuesday in 2 weeks from now. And basically the workshop will be a very hands-on tutorial in which you will write your first Starknet contract in Cairo. And the nice thing about Starknet is that basically it abstracts away from the developer everything which is related to proof systems. So you as a developer can write your smart contracts, and the protocol does all the work which is related to the proof system for you, the same way that you don't think about proof of work when you're writing Ethereum smart contracts. And basically the programming paradigm is very, very similar to Ethereum. So the workshop will guide you through writing a voting application over Starknet, which is a very, very good example on the scalability potential of proofs, because it's a highly computational application, which at the end has one result. So we can very easily see the scaling properties of the system. So yeah, this is Starknet. This is the workshop. It will be on the 9th of November, as I've said. I think it's a very good gateway both to Cairo and for Starknet, and it will be very interesting. So I hope to see you there. And again, thanks.
Awesome. Thanks, Tom. Next up, I want to invite Chris to the stage. And I think we have your slides here as well. Hey, Chris.
Hello.
So Chris is going to be presenting Anoma.
All right. I set up in a reminder, of course, of how far technology has not yet come, a second monitor solely for the purpose of slide sharing. And so far it appears to be working. So if my eyes keep darting in a weird direction, it is not because I am waiting for a mysterious delivery. It is because I'm looking at the other screen, just so you know.
Right,
and I am going to talk about Anoma. So what is Anoma besides a sponsor of ZK Hack? Go figure. Anoma is a protocol stack for economic coordination with and amongst self-sovereign communities, which sounds very general and kind of vague. And I'll talk a little bit about what that actually means, but that is the high-level goal. We want to facilitate communities which control their own systems of coordination, so there isn't a sort of misalignment. If you look at, say, a fiat currency, that's an example of a misalignment between the mechanism which a community is using for coordination and the entity who actually controls or enforces the rule set of the mechanism. So we want to facilitate economic coordination amongst self-sovereign communities, communities that control their own mechanisms. How do we do that? There are three basic components of the Anoma protocol stack. first component is the intent gossip system. So the intent gossip system is a custom gossip network. You can think of it as a kind of generalized, decentralized order book. So using the intent gossip system, you as a user of Anoma can broadcast your intent. And an intent is like just saying that you'd be happy to make a certain state change in exchange for some other state change. You'd be happy to trade something for something else. You'd be happy to barter a blue-eyed CryptoKitty for a red-eyed CryptoKitty, whatever it is that you might want to do. If you can write that as an intent, you can send it to the intent gossip system. Then the matchmaker algorithm, which can be run by anyone, that's stage 2, is responsible for finding perhaps 2 or perhaps many more than 2 intents, which can be combined together into some kind of transaction. So the matchmaker is responsible for finding reassignments of assets that satisfy everyone's preferences or make everyone better off, or so to speak. The third component, and the one that you're probably most familiar with, is the settlement ledger or blockchain, which is a custom proof-of-stake blockchain protocol designed for private settlement of these kinds of end-party bartering transactions. So first, you create intents expressing what you want to do. Then matchmakers, perhaps you, perhaps someone else, find groups of those intents which are compatible with each other, which together can be used to reassign assets in a way or make state changes in a way that everyone is happy with. And then those transactions can be submitted to the ledger and everyone can be happier. Sounds great, right? All right, where does cryptography come in? Wait, just kidding. Why private bartering? Very important question. So the reason we're going for this angle is sort of our answer to the question of what is a blockchain for? When you think about like what in the very broad sense of like what is it that this technology does which is useful? What is it that we're going to remember in 100 years? Personally, I don't think it's DeFi. We want to go for allowing people who want to exchange goods for which we need a kind of economic mediation system, like say physical goods, which are actually scarce. We want to allow the exchange of goods in a way to think about this is if you spend, let's say that you are a cryptographer. So you're producing, what are you producing? You're producing cryptography research, like you're writing papers and submitting to conferences or to ISCR, or you're working for a blockchain company perhaps, or you want to. And then, you produce your cryptography research in the morning, and then at lunch, you go buy some food. So if you think about it, you're using money, but you're using money to intermediate this very complex, large economic network, because boy, the guy who's giving you doner kebab for lunch probably doesn't want your cryptography research, no offense. And you're relying on this complex network of interacting economic agents to do a bunch of like bipartite or exchanges among small numbers of parties that ultimately allow via many, many swaps you to get doner kebab in exchange for cryptography research. But the problem with using money as a mechanism to mediate all of this exchange is that money is unidimensional. So when you use money, you're not capturing all of the interactions and all of the causal ramifications along the supply chain, which you might care about, say carbon externalities of companies which are competing with each other and could figure out ways to produce cheaper soda bottles by dumping more carbon into the atmosphere. You actually don't want that, but because the only difference you see is a price, it's very difficult to incorporate these kinds of multidimensional impacts into your preferences. So we think that what blockchain should be doing is using the fact that they can do a bunch of computation to disintermediate, not necessarily not only at least the sort of human entities like banks or something involved in mediating economic transactions, but also the currency itself, so that the representations of what you're doing could be higher dimensional. So that's why we're going for private bartering. But to make it private, we need some cryptography. So there are 3 main cryptographic components of Anoma, and there are many more cryptographic components, but these ones I want to highlight. The first are, and perhaps a flagship, are the circuits for private bartering, which allow you to do programmatic swaps in private, partially in private in the intent gossip system, because you need to reveal a little bit about what you want in order to find counterparties, and fully in private on the ledger, so that observers can see absolutely nothing. So using the private bartering circuit, you can conduct multi-party swaps, you can write limit orders, you can swap any blue-eyed CryptoKitty for a red-eyed CryptoKitty, all in private, so that observers of the ledger cannot distinguish any transactions to the circuit at all. The second component I want to talk about briefly is the Fairview system for distributed key generation and threshold encryption decryption. Many of you may have heard of MEV, or the front-running problem, fair transaction ordering. We think this problem can mostly be solved with cryptography, and when you could solve a problem with cryptography, then you don't need to think about game theory, and I'd rather not think about game theory. So we're trying to solve front-running with cryptography using Fairview. And the third component is Plonkup, which is a protocol fusion of Plonk and plookup that creates a flexible polynomial equipment-based proof system, and we're working on a standardized IR so that all the different flavors of Plonkup and Halo 2 and things that are Plonk-ish but not entirely standardized can be targeted with front-end languages through standard IR. We are giving a workshop, which may soon be retitled to Plonkup in You. I think there's currently a longer title, which is entirely my fault. The workshop will cover a few tasty details on cryptography and Anoma, what I talked about earlier in more detail, plus a few other bites that you might find interesting. And then we'll give a walkthrough of Plonkup and teach you how to use lookup gates, which might be something useful to your zero knowledge projects. Catch us on the 16th of November. And finally, we have built some puzzles for everyone. I am told in no uncertain terms that I cannot reveal any details of said puzzles, but they are titled Group Dynamics, Hidden in Plain Sight, and Soundness of Music, which I can only assume is an allusion to the musical, but I actually don't know. Thanks to Simone, Joshua, and Joe for creating these puzzles, and you will find them released on the ZKHack website and through appropriate channels, whatever those might be, on the 2nd, 16th, and 30th of November, I think. Double check that one, but good luck. And if anyone finds out whether this is an allusion to the musical or not, or how, please let me know. Thank you very much, and good luck with ZKHack.
Amazing. Thank you for Chris for not sharing more. I was going, oh man, he's going to talk about the puzzles. Yeah, we've worked pretty hard to try to keep these as underwrapped as possible. But yeah, thank you so much for the talk.
Thank you.
Next up, we have Zach from Aztec. Hey, Zach.
Hey everyone, how's it going?
Good. Take it away.
Awesome. So yeah, I'm Zach. I'm the CEO of Aztec, and I'm here to talk about Aztec Connect and to talk about our workshop if anybody is interested in learning how it works. So what Aztec Connect is it's a mechanism to interact privately with layer 1 smart contracts through a layer 2 ZK Snark-based network. At the moment, it's just our network, but the idea is that the interface that we're developing is supposed to be generic enough that it could be supported by multiple different protocols. So our workshop is going to be a little bit more high level than the others, and mostly geared around Solidity developers that want to kind of get into zero knowledge crypto, aren't really cryptographers, but still want to play around with the tech and do something useful with it. So what Aztec Connect is my computer's not working. Okay, here we go. So it's effectively private DeFi aggregation, where we use ZK Snark proofs inside the Aztec layer 2 to aggregate private transactions together. And then when a rollup block is broadcast into mainnet, the kind of the aggregated transaction gets sent as a single kind of meta transaction to a given layer 1 smart contract. And you can use this to both ensure you have privacy. You can engage privately with existing layer 1 smart contracts, existing protocols on chain without them doing a thing, and also to allow for cheaper transactions because these things get aggregated together. And so the idea is that this bridge interface that we've developed is suitably generic, that it can interact with the large majority of interesting layer 1 protocols. So like the example here is Uniswap, which we'll be going into in a lot more detail in the workshop, as well as in the workshop we'll be explaining how the cryptography works and also implementing some example smart contracts and talking a little bit more about the our Gitcoin grants program to develop these bridge contracts for protocols that you're interested in. If that's something that you'd be interested in, that you would appeal. So yeah, that's basically just some about transaction costs. But what I wanted to get to is, yeah, basically it's all done in Solidity. We have a relatively standard interface to talk to layer 1 smart contracts, but the benefit is obviously your transactions are private, and this will enable some interesting novel use cases on Ethereum, that can't be really exploited at the moment. Things like fully blind auctions, private voting, private DAOs, that kind of thing. And so, yeah, looking forward to seeing everybody at the workshop, looking forward to seeing everybody's solutions to these puzzles. And thanks for listening.
Thanks for the presentation, Zach. Coolio. All right, next up, I hope that Alex is ready to come on the screen. There you are. Okay, perfect. Hey.
I hope so too. Can you
I
hear
hope
me?
so too. Yeah, I can hear you. Do you want me to just wait till you click through a slide?
Yeah, sure. Let's kind of check here and make sure everything works and it's all right for sound.
Exactly.
Okay, cool. I hope you can see these slides, everyone. Let's just check. Okay, cool.
Perfect. Okay. Take it away, Alex.
Great, thanks. Hey, everyone. I'm Alex Pruden. I'm the COO of Aleo. And yeah, very excited to be here today. This is a real pleasure for me. I'm really very passionate about the space, and I'm excited to partner with Anna and her team in something that I think is really great. I think the best way to learn is by doing, and the opportunity, to kind of do these puzzles, I think is going to teach a lot of people a lot of things. And I think it's a fantastic opportunity to learn about all the really exciting different directions that people are taking to make this accessible to the average developer. So with that, so let me talk a little bit about Aleo. So Aleo is kind of our tagline is, where applications become private. So what are we talking about? What does that mean? So Aleo is a new layer 1 blockchain. So a lot of folks are building on Ethereum and doing interesting stuff there, and I'm very excited about that as a major Ethereum holder and fan myself. But we're taking a slightly different approach. We've got a new layer 1 blockchain, and we're building in this model called ZKValidator. So those of you in this, some of you in this, in this workshop or at this event might be familiar with ZKValidator. It stands for zero knowledge execution. And it was written as a paper written a few years ago. The date is the updated paper, but I think it was originally released in 2018. And the high level idea is basically off-chain compute and on-chain verified. This is actually not that different than what a lot of what folks are doing with the roll-up model. But this is kind of arguably a little bit more generalized, and we do have our own layer 1 blockchain where we're storing the records or kind of the proofs themselves. So we're kind of taking a full stack approach up to private applications, which is kind of why we have our tagline there. So highly recommend you read the paper if you haven't. There's also some great, I'll just plug, if the paper's too dense for you, there's some great blog posts on the zeroKnowledge.fm website where people have summarized these ideas too, and they're really exciting. So definitely recommend you check that out. Okay, back to Aleo. So yeah, so like I said, we have our own layer 1 blockchain. That's what we call SnarkOS at the very bottom layer there. And the execution environment is really where we kind of implement this idea of ZKValidator, which is running state transitions or running proofs of state transitions off chain on a client side or through a prover, a trustless prover, and then those state transitions get kind of bundled up as proofs or generated as proofs, bundled into transactions and submitted to the layer 1 blockchain, which we call SnarkOS. And then the focus of our workshop is going to be what we call Leo, which is a new language and compiler for writing private applications using zero knowledge proofs. And last but not least, we've built a bunch of dev tools to help developers kind of make this a little bit more accessible. So Aleo Studio is where you can write a Leo program. We also have a web IDE at leolang.org, and I can share some links in the chat after this for folks who want to learn more. We have a package manager, which is actually something I'm really excited about. In Ethereum world, I think there's about 1 million copies of copies of safe math floating around, and it kind of introduces some security holes sometimes, as we've seen in some hacks. So the package manager is effectively a namespace, and package manager just it's kind of like Node or others from different ecosystems, and basically lets you write a package or a library once, and other people can import that into your application. So hopefully reducing the potential errors that occur when you Control-C, Control-P across smart contracts. And then Aleo Explorer is a block explorer, and you can directly deploy application and see the transactions kind of flowing through that. Okay, cool. So I talked to like I said, really our workshop is about Leo. And one of the things that I'm excited about for Leo is we're working to have this language and compiler formally verified. And I think that's exciting because, as we've seen, when the logic of your program, is potentially private or potentially not being revealed, you always have to worry about a bug that gets introduced at some layer of the compiler, wherein there's something that's not according to plan. Zcash, I think there was a bug in particular where there's a question of like, well, is this potential bug would let people mint an arbitrary amount of Zcash, and people had to wonder, well, had anyone taken advantage of this? You don't really know or not know. So this obviously, having formal verification for your compiler doesn't mean that there aren't developers who can't find a way to write bugs, but it does mean that those bugs hopefully are impossible, mathematically impossible, at least from the level of the compiler. So we really value the idea for security as well as privacy, and so this is something that we're very kind of passionate about. And I mentioned some of these other things. Like I said, leolang.org is the best place to kind of get a feel for this language in advance of the workshop. And during the workshop, we'll kind of go through an example application. But for those of you who've written Rust and JavaScript before, it's kind of a mashup of those two languages. So check it out. Cool. Yeah. And then I think really this kind of applies beyond Leo, but just to all the talks. I think one of the really exciting things about all these languages that you all are going to be learning about is, no longer will you need a PhD to write circuits for zero knowledge proofs, right? You'll have compilers, and Alex Ozdemir, who, if you haven't heard his earlier talk, it's fantastic, but he kind of goes through kind of the taxonomy of languages, and at a high level, like it's very exciting to make this technology accessible to the average developer, not just the cryptography expert. Cool. There's the link right there, actually. So play.leolang.org. So I encourage you to go and check it out. We've got some packages on there that you can, kind of start from. We have a linear regression example, for example, some other stuff. And and so like, what kind of stuff can you build? I came up with this idea for a workshop I did recently of a medianizer for oracles. So, a lot of DeFi systems rely on oracles to report price feeds, and some, kind of as an additional layer of security, instead of just trusting one oracle, they aggregate a bunch of oracle reports into a single value. And one way to do that is just take the median value of a report, of an array of reported values. This is what MakerDAO, at least up to a year ago. I haven't really been following them recently, but I know they were doing something like this for a while. And one example application we have in the playground that you can play with is kind of this idea of a private medianizer where the reported array of values isn't publicized, and the identities of the reporters are not publicized, but you can get a cryptographic proof along with a value associated with it that's the median value of some array of reported numbers. So anyway, it's just one of many, many, many examples that I'm sure you guys will hear about for zero knowledge powered applications. And like I said, thank you very much again to Anna and the ZK Hack team for having me here. It's our pleasure to sponsor this event, and very, very excited for the rest of the next several weeks. So thanks again.
Thanks so much, Alex. Thanks for the presentation. I'm glad it worked. Cool. All right. I want to invite Izaak from O1 Labs to talk about your workshop and Mina. Go for it.
Cool. Can you see me in my screen okay?
Yep, you're all good.
Great. Hey, everyone. So I'm Izaak. I'm CTO at O1 Labs. And you may or may not know, but O1 Labs works on Mina, which is a layer 1 blockchain that launched earlier this year. And the slide's kind of busy. But basically, Mina uses recursive ZK snarks to compress the whole blockchain into a single ZK snark, which lets anyone on the network sync pretty much instantly with the security of a full node. So that's Mina. And where Mina is going is Snaps. So Snaps is going to be our first major hard fork for Mina. And it's basically our system for private, scalable smart contracts. dApps, just to kind of give you a quick gist of this, dApps are applications with public data and censorship-resistant execution. Snaps, which are smart contracts on Mina, are applications with both optionally, private and public data, censorship-resistant execution as before, but now also verifiability and scalable execution. So these are kind of the three new things you get by using ZK Snarks. You get privacy, verifiability, and scalability. Now, as for our workshop, that's going to be on December 7th, and we're going to be exploring Snarkyjs, which is our TypeScript SDK for working with zero-knowledge proofs, and also Web Snaps, which is Mina's system for importing real-world data into zero-knowledge proofs. So let me just say a bit more about these two things. Snarkyjs, it's our TypeScript SDK. Here you can see an example of it. This is just like a little bit of TypeScript code for verifying a Schnorr signature. And the really nice thing about it is there's no need to learn a new language or tools. You can just use TypeScript, VS Code, which has really nice like autocomplete and like, error indicating and stuff, and NPM. You don't need to learn anything new. And then Web Snaps, so that one kind of way of communicating it that Emre, our CEO, came up with that I really like was a private Plaid for anything. So Plaid is sort of, this weird hacky system for like getting data out of US banks that don't have APIs. This is sort of a system for doing that, but importing it into zero-knowledge proofs and any kind of data from the web. So let me just kind of set the background a little bit. Zero-knowledge applications have been pretty limited, I would say, so far. Like they're limited beyond, the actual applications that we've seen are kind of surprisingly few and just been limited to games and financial speculation in theory. I mean, I'm not sure there's even been that much of like private DeFi stuff yet, but it's doable in theory. And the reason is because there's no way to import real world data. So you're just limited to kind of the internal reality of a blockchain. So you can just do games or just do financial speculation. Web Snaps is a really neat feature that's part of Snarkyjs, which will basically let you import any data from the web into your zero-knowledge proof. So if the data is accessible via HTTPS, it can be imported into your zero-knowledge proof. So like, just to give you an idea of this, there's a few examples. You could really easily make a proof of identity contract by just, saying, oh, I can access, a Facebook account that I control and has at least this many friends, or, I can go onto a government website and I have a valid login there. And so that can be like a proof of identity. You can also use this technology to like use medical information in an application, or you could use data from social media while still protecting the user's privacy. So for example, maybe you want to like bootstrap a new social media platform, and you want to automatically let people become friends if they're already friends on some other platform. So you could just like kind of import that data from an existing social media website onto your like new private social media. The examples go on and on. Unsecured lending with credit scores, for example, this is kind of something we're working with Teller Finance on. And other examples are you could have kind of like employment verification or some kind of accreditation verification while still protecting the user's privacy. So normally, most of these applications don't really make sense on a blockchain because in a dApp, like all data has to be public, but in a snap, you can keep data private. And with Web Snaps, you can like use existing data sources like out of the box. So, private DAS, sure. So that's pretty much it for like the a teaser of what you can expect to learn about at the workshop. But just a few plugs. We're hiring at ON Labs, so a bunch of engineering positions: head of marketing, head of biz dev, senior technical product manager. Link is there, and just a few things to know that are unique about ON Labs. Perhaps not unique, but some of them are. Very good comp and work-life balance, friendly, kind, and smart coworkers, very cutting-edge technology, of course, and products. And then the most unique thing I would say is we're majority worker-owned and 100% worker-governed. So, everyone really controls the workplace. So the hackathon, not ton, is going to be, we're also having a Snaps hackathon, sorry. This is unrelated to this event, but it will be a few days after December 7th, so after our workshop. And if you want to make any feature requests for Snarkyjs, here's a link. I'll drop a link to the slides in the chat so you can get all these links. And also, again, the jobs. Oh, and you can follow us on Twitter. Okay, that's it for me. Sorry, I kind of rushed through it, but.
No, not at all. Actually, we're a little early, but thank you so much for your talk and sharing with us the workshop. I've been adding all the links to every single workshop. Those are all unique hop-in links, and you can already sign up for those now, even though in your case, it's on December 7th, so it's quite a ways in the future. You're going to be hearing about all these workshops week to week as well, but if there's some that you're like, I must not forget it, now's a good time to sign up. All right, thanks so much.